Welcome back to the deep dive. Our mission, as always, is pretty simple. We take the source material you send our way, articles, research, notes, whatever you've got, and we really dive in.
Yeah, plot the key insights, the interesting details, the stuff that really matters.
Exactly. Help you get up to speed quickly with enough context so it actually, sticks. So today we're tackling infrastructure choices. It's something pretty much everyone developing software bumps into eventually.
Mhm.
We've got a really interesting case study here. It's based on an article called Building Better Builds After Fly.io Failures. It was written by Jonas, who's a co-founder over at Sliplane.
Right, and this is a classic story, in a
Yeah.
way. A company, Sliplane, needed to do something pretty specific, run Docker builds for their customers. Critical stuff.
Yeah.
They picked a popular platform, Fly.io, to handle it. But, well, the title gives it away. It didn't quite work out as they'd hoped.
Right. So that's our mission for this deep dive, figuring out why it didn't work, what were the technical reasons, the business reasons, what problems did they actually hit.
And what did they end up building themselves? It really gets into that whole buy versus build calculation.
Yeah, but with some really specific wrinkles, the kind of hidden details that make you realize these infrastructure decisions aren't always as simple as they look on the surface. Wait, so let's jump in. First off, to really get why this build system was so important, what exactly does Sliplane do, and what was this need they had?
Okay, so Sliplane offers managed hosting specifically for Docker apps. And a really core part of that service is taking a customer's Docker setup, their image, and actually building it.
So it's not just some background thing, it's central to their offering.
Absolutely central. It's how a customer's app gets deployed. So this build system needs to be, well, solid, reliable, fast,
Makes sense. And I'm guessing they had some pretty specific technical needs for how those builds should run.
Oh, for sure. The article lays out a few key ones. First, every build needed total isolation, like its own separate VM. That's crucial for security, keeping customer stuff apart.
Right, standard practice, but important.
Yep. Then fast boot times for those VMs. Customers don't want to wait ages just for the build environment to spin up.
Yeah, impatience is universal there.
True. Persistent volumes were also key. They needed that for Docker layer caching. Makes a huge difference in build speed if you're building similar images repeatedly.
Oh yeah, caching is everything for Docker builds.
Exactly.
Right.
And the last thing was this idea of auto-suspend and resume. Basically, if a build VM wasn't actively building, they didn't want to pay for it just sitting idle. Cost saving.
Okay, so isolated VMs, fast startup, persistent volumes for caching, and suspend resume for costs. Got it. And looking around, Fly.io must have seemed like it could handle that.
Yeah, I mean, on paper, it looked like a really good match. Fly.io uses Firecracker for virtualization.
Which gives you those lightweight, fast VMs.
Right, and the isolation they wanted. Plus, Fly has this feature that they call it wake on request. Sounds a lot like that auto suspend resume behavior, doesn't it?
It really does, yeah.
And they offered persistent volumes, scalable up to 500 gigs. Seemed like plenty for Docker caching. So, yeah, it looked promising.
So how did they actually set it up initially? What was the plan?
It was pretty logical. Based on how Fly works, they'd create a separate Fly app for each customer.
Okay.
Then, when a build was needed for that customer, they'd just send an HTTP request to that customer's specific Fly app. The idea was Fly would automatically wake up the VM if it was asleep, run the build inside it, handle the resources.
And did it work at first?
Yeah, the author mentions that initially it seemed okay, caching worked, boot times were decent enough, the whole approach felt, clean, like the platform was doing what it promised.
Ah, but then comes the but. That initial success didn't hold up under real load, right? This is where things started to unravel.
Yeah, this is the breaking point Jonas describes. As more customers came on, as usage grew, they started seeing these really nasty, unpredictable failures.
Like what specifically?
All sorts of things. VMs just failing to boot. They'd get out of capacity errors, even when they thought they were well within limits.
Ugh, capacity errors are the worst. So vague.
Totally. Then those suspended apps that were supposed to wake up on request, sometimes they just wouldn't. They'd stay dead.
Oh, wow.
And worse, some VMs would apparently just die mid-build or sometime after with zero logs. No way to know what happened, no recovery, just gone.
Yikes. That's bad.
And then there were the hidden limits. They started bumping into undocumented quotas. Things like subtly discovering there's a maximum number of apps you can have or maybe volumes per region that just weren't advertised anywhere.
Oh, man, undocumented quotas. That sends shivers down your spine when you're relying on a platform. What was the actual impact? How bad did it get?
It got really bad. They estimated eventually that something like 10% of all their builds were failing. 10%.
Wow. And critically, these weren't user errors, like bad Docker files.
No, that's the key point Jonas makes. These failures had nothing to do with the customer's code. It was purely the infrastructure underneath failing them.
A 10% platform failure rate for a core feature.
Yeah.
That's just untenable. I bet they tried everything to fix it, right? Workarounds, retries.
Oh, absolutely. He talks about building all sorts of resilience layers on their end. Sophisticated retry logic, specific workarounds for the failure modes they could identify, tons of extra logging to try and figure out what was going on.
But it sounds like it wasn't enough.
No, because the fundamental problems, the root causes, were deep inside the Fly.io platform's behavior under their specific kind of load. And those were things Sliplane just couldn't control or fix from the outside.
So, okay, they hit this wall. They couldn't fix it with workarounds. They needed to understand why it was happening. What was the mismatch?
This is where the analysis gets interesting. It boils down to what Fly.io seems optimized for versus what Sliplane actually needed for these builds. Fly seems really geared towards, lots of small, generally stateless web applications, things that benefit from being distributed globally, close to users, maybe scaling horizontally.
Right, the typical edge pass use case.
Exactly. But Sliplane's build workload was almost the opposite. These weren't small VMs. They needed serious whack.
Jonas mentions 16 to 32 gigs per build VM. That's pretty chunky.
Yeah, much bigger than your average web server instance.
And they hammered those persistent volumes constantly for caching. It wasn't occasional excess. It was heavy, continuous read-write. And that needed to work flawlessly, even when VMs were suspending and resuming.
Okay, so if Fly is tuned for small, stateless stuff, Sliplane was throwing big, stateful, volume-heavy workloads at it and relying heavily on suspend resume working perfectly under load.
That seems to be the conclusion, yeah. The internal mechanics of Fly, how it schedules big VMs, how it manages those persistent volumes, especially during suspend resume cycles when things are busy, just wasn't designed or robust enough for that specific pattern.
And it's interesting, the author has a little warning note. Fly has been talking more recently about supporting AI agent workloads, which might have some similar characteristics needing state, maybe bigger resources.
Right.
And based on their bad experience with builds, Jonas basically says, be really careful. Benchmark the heck out of it if you're thinking of using Fly for that kind of thing.
That makes sense. So when the platform isn't working, the next logical step is often, okay, can we just buy a service that specializes in this? Did they look into dedicated Docker build services?
They absolutely did. He specifically mentions looking at Depot, which by all accounts is a solid service for doing exactly this fast, isolated Docker builds. Jonas even says it's a great option for many teams.
So the buy option existed. Why didn't they go for it? If it's good for others.
Yeah, this is really crucial. It came down to the business model. The way services like Depot charge just didn't work for Sliplane's business.
How's
Well, Depot and similar services, they typically charge based on usage, per build minute plus storage costs for the cache data, usually per gigabyte per month.
okay, metered billing. Seems standard for cloud services.
It is. But when Sliplane ran the numbers, using a service like Depot would have cost them something like 4 to 5 times more than what they were paying even on Fly, let alone what they could potentially build it for.
Wow, 4 to 5 times. That's a huge jump. But hold on, building it yourself isn't free either, right? You've got engineer time, maintenance. Does the article just focus on the raw infra cost?
That's a fair point. The article definitely emphasizes the direct cost difference as the primary driver here. The hidden costs of building are real, for sure. But the argument is that the variable metered cost of the buy option created this fundamental conflict with how Sliplane actually makes money.
Ah, right. You mentioned they charge customers per server, not per build.
Exactly. So imagine a Sliplane customer who maybe doesn't deploy new code that often, but when they do, they run tons and tons of builds, maybe testing CI branches, experimenting.
Right, build heavy but low server count.
Yeah. If Sliplane was paying Depot per minute for all those builds, that customer could easily become unprofitable. The only way around it would be for Sliplane to start charging their customers for build minutes.
Which adds complexity, friction, changes their whole value proposition.
Precisely. Their goal, as Jonas puts it, is for builds to feel free to the customer. Part of the simple, predictable package. Keeping their own billing straightforward meant they had to control the underlying build cost directly. That financial reality tied to their business model basically forced their hand towards building it themselves.
Okay, that makes a lot of sense. Platform failed, specialized services clashed with the business model. build it is. So what did they actually construct? What's this homegrown solution look like?
They essentially rebuilt the core idea, but with direct control. They're still using Firecracker for the MicroVMs.
Okay, so Firecracker itself wasn't the problem.
No, seems like the orchestration around it was. So they run Firecracker, but now it's on their own rented bare metal servers.
Ah, ditching the platform layer entirely.
Exactly. Gives them total control. So each customer build gets its own dedicated Firecracker MicroVM. They use NVMe drives for the persistent volumes, super fast I/O, which is critical for Docker build performance.
Right.
And because they control the metal, they can manage resource sharing themselves. They do RAM and CPU overcommit right there at the hardware level, packing multiple MicroVMs onto a single physical server efficiently.
And they wrote their own software to manage this whole dance.
Yep, a custom orchestrator written in Go. And get this, Jonas says it's only about 4,000 lines of code.
4,000 lines. For the core orchestrator of their build system, that seems incredibly small.
It really does, right? But he chalks that up to it being extremely purpose-built. It only does what they absolutely needed to do for builds, nothing more.
Okay, so why does this custom setup work so much better for them than Fly did? What's different about how it handles their workload?
It goes back to the pattern of their builds. They don't actually have a massive number of builds running at the exact same second across their whole infrastructure.
Hmm.
On any given physical server, the number of concurrent builds is relatively low.
Okay.
And the builds themselves are bursty. They'll hammer the CPU for a bit, then wait on the network, then hit the disk hard, then maybe wait again. They aren't constantly using max resources.
Ah, so that burstiness makes them good candidates for sharing resources on one machine.
Exactly. Perfect for overcommitting CPU and RAM because, on average, not everyone is demanding peak resources simultaneously. Jonas mentions that even when they're busiest, their build servers are typically sitting around only 20% average utilization.
20%. That's amazing. That predictability must be such a relief compared to random out-of-capacity errors.
Has to be, yeah. And because that custom orchestrator is so lean, it avoids all the complexity of a general-purpose system.
What does it actually do, then, day to day?
It's pretty simple. It gets a request for a build. It boots up a Firecracker MicroVM for that specific job. It attaches the right NVMe-backed volume for that customer's cache. It tells the VM to run the build commands. It monitors it. And when the build is done, win or lose, it just cleans up, tears down the VM. Rinse and repeat.
So no complex networking, no service discovery, no managing long-running containers or pods. Just start, run, stop.
Pretty much. They skipped everything they didn't need, all of the stuff that makes general platforms powerful but also complex. That's how they kept the code small and presumably the system reliable for their specific task.
Okay, looking back then, what are the big wins they got from going down this build path? What are the concrete advantages?
Well, they directly solved all the problems they were having. No more capacity errors because they control the hardware allocation. No more hidden limits because they wrote the scheduler.
Makes sense.
Builds are actually faster now. They attribute that to the direct NVMe I/O and probably less overhead or latency in starting the VMs compared to the platform. They got full observability. They can see exactly what's happening inside their own system. Predictable performance. No more surprises from a third party changing things under the hood.
And the big one, cost?
Yeah, the cost.
Yeah.
That was a huge driver.
Yeah.
Jonas estimates their cost per build now is somewhere around 20 to 30% of what they were paying on Fly.
20 to 30%. That's a massive saving. That directly supports their business model of not charging extra for builds.
Exactly. It makes their pricing model sustainable.
But okay, there's always a trade-off. You don't get something for nothing. What did they give up by ditching the platform and building this themselves?
The main things they lost were the broader platform conveniences, specifically things like Fly's global network capabilities and the general ease of use of APIs.
So like built-in global load balancing, easy CDN integration, maybe simpler deployment workflows.
Yeah, things like that. Global routing, the deployment tooling that's often tightly integrated, that whole zero config infrastructure feeling you sometimes get with a good PaaS. They traded that away.
But it sounds like for this specific workload, the builds that trade-off was worth it.
Definitely. Jonas makes the point that for builds, customers care way more that they just work reliably and quickly wherever they happen to run, rather than needing the build process itself to be globally distributed at the edge. Reliability and cost trumped global convenience for this core task.
It sounds like a very clear-eyed decision about what mattered most for this specific piece of their infrastructure and their business.
Yeah, very deliberate. They focused resources on controlling what was essential.
Okay, so as we wrap up this case study, what's the advice Jonas offers? Who is Fly.io good for based on their experience? They still use it for some things, right?
Yeah, they're careful to point out this isn't a Fly is bad post. It's about workload mismatch. They actually still use Fly for some other internal stuff.
Okay.
So they say Fly is likely still a solid choice for, MVPs, side projects, smaller apps that aren't super resource hungry or stateful. Stateless web apps, things that really benefit from that global edge routing Fly, can be great for those.
But who should maybe pause and think twice based on Sliplane's painful lessons?
Well, based on their struggles, probably anyone looking to run CI/CD build systems on it, anything that needs consistently large amounts of RAM per instance, or relies really heavily on persistent volumes, especially with suspend resume, and basically any critical infrastructure piece where you absolutely need predictable performance and can't tolerate unexpected resource limits or platform hiccups.
And the number one takeaway, the key piece of advice for anyone evaluating any platform for something important.
Try it first, for sure.
Mm.
Platforms are great starting points. But, and this is the big one, benchmark it. Benchmark it hard, with realistic load that actually mimics your real usage patterns. Don't just kick the tires with a Hello World app.
Yeah.
Don't just assume that because it feels easy to get started, it'll automatically scale reliably for your specific, potentially demanding workload. You have to test that assumption.
That really feels like the core lesson here, learn the hard way. And Jonas is pretty honest about that, isn't he?
Oh yeah, totally. The article has this great candid line near the end. Yes, this is entirely our fault for not testing harder up front. That smiley face doesn't quite hide the pain, I suspect.
Yeah, probably not.
But it really drives home that point. Validate the platform against your needs. Don't just trust the marketing gloss.
Absolutely. Sliplane's story is just such a powerful example. These easy button platforms, they're fantastic for so many things, but they can have sharp edges or hidden cliffs depending on exactly what you're trying to do. Or even, like in this case, how your business model interacts with their pricing. It really makes you wonder, doesn't it? How much are you, listening right now, really stress testing your critical infrastructure choices before you build your business on top of them? And are you thinking about the total cost, not just the monthly bill, but those potential conflicts, the operational risks, the limits it might place on how you want to serve your customers, platform versus purpose-built?
Mhm.
It's a question worth revisiting for your core processes, something to think about.